Welcome to Business Talk, a global podcast series where we bring you closer to some of the world's most distinguished scholars and their impactful ideas. I'm Deepak, your host from India. Imagine standing beneath a vast night sky, billions of stars stretching endlessly above you, each one a sun, and perhaps each one a home to worlds we have yet to discover. It's a thought that has captivated humanity for centuries. But for our guest today, it's not just a poetic thought, it's a life work. Professor Chris Impey has spent decades asking the questions that keep us up at night. What is out there? How did it all begin? And most boldly, are we alone? As a university distinguished professor of astronomy at the University of Arizona, Dr. Chris has built a career that is as vast as the cosmos he studied. Over 450 publications, more than $20 million in NASA and National Science Foundation grants, research spanning the farthest reaches of our universe from distant sources to the large-scale structure of galaxies. But here's what makes his story truly extraordinary. At a time when science can feel cold and distant, Dr. Chris Impey made it warm, accessible, and deeply human. 11 teaching awards, 4 online courses that reach over 420,000 students worldwide, with more than 8 million minutes of video lectures watched, the National Science Foundation Distinguished Teaching Scholar, the Howard Hughes Medical Institute Professor, Carnegie Council's Arizona Professor of the Year, and the American Astronomical Society's Career Education Prize. His classroom quite literally has no walls. And there are and then there are the books, 10 popular science titles, 2 textbooks, 120 articles, and even a novel. Works like Einstein's Monsters, How It Began, and Dream of Other Worlds have carried the wonders of the cosmos into living rooms, coffee shops, and curious minds across the globe. Today he brings us into one of the most thrilling frontiers of modern science, the search for worlds beyond our own. His book, Worlds Without End, Exoplanets, Habitability, and the Future of Humanity, asks a question that may define our species. Where else could life exist? And what does that mean for us? Professor Chris, you have been spent a lifetime making the universe feel like home. We are truly delighted to have you on Business Talk. The honor, without question, is entirely ours. Thank you so much and a very, very warm welcome.
Yeah, it's great to be with you. Looking forward to the conversation.
Thank you. Professor, the title, World Without End, feels both poetic and scientific. What does that phrase mean to you personally, and what moment in your research made you truly believe that habitable worlds beyond Earth are not just a possibility but an inevitability?
Well, this is a field that's been moving very rapidly. So, since the first detection of a planet around another star in 1995, the number has grown to over 6,000. And we're only looking in the nearby part of the galaxy. So, worlds without end imply there are an infinite number of worlds. Well, there are billions of habitable worlds in the Milky Way, which is an incredible number. And it's just watching the thrust of that research that made me excited about this subject and want to write a book about it.
Professor, you describe Earth as perhaps not the best of all possible worlds. That's a bold claim. What does the science of exoplanets actually tell us about how special or ordinary our planet really is?
It's an interesting question because it's still the only planet we know with life on it. We have to be clear about that. But astronomers have found worlds that are habitable in the sense of being stable climate, liquid water could be on the surface, the right temperature for life, and so on. And and when you look at the properties of these planets, the Earth is actually a little more unstable or unusual. There are over long time periods, there are big climate fluctuations, there are impacts from outer space. So there are exoplanets that may be in more stable environments than the Earth. So while it's a pretty good planet, and we like it a lot, of course, it does not have to be the best of all possible worlds.
Professor, the first exoplanet was discovered only in 1985, and we have now identified over 4,000 more. In your view, what has been the single most surprising discovery in this field? The one that made astronomers say, we did not see that coming.
The one that no one saw coming happened very quickly because the first exoplanets discovered were like Jupiter. They were as massive as Jupiter, but they were very close to their stars, much closer than Mercury is to the sun. So giant planets close to their stars, that was unprecedented. That was a shock, a surprise, unexpected. And actually, in the end, we had to decide that the planets were not born there. They had to move there and migrate there. So very early in the history of this subject, we saw these anomalous systems, giant hot Jupiters as they're called, and also learned that planets move, that they don't always sit in their same stable orbits. So that transformed the field to understand that, because it may have happened in our solar system too.
Professor, the Kepler satellite has been a game changer in detecting Earth-like planets. How do scientists actually determine whether a distant planet is habitable, and how confident can we really be in those assessments from billions of kilometers away?
Yes, it's good that you mentioned Kepler. So, and Kepler is an unsung hero sometimes beyond the world of astronomy in terms of our facilities. It's a modest-sized telescope, only 1 meter across. In the world's largest telescope, if you make a list, it wouldn't be in the top 70. But NASA built this mission, and in the early 2000s, it's found really more than 2/3 of all the exoplanets we know. This little 1 meter telescope just looking for transits or eclipses. So Kepler was a transformative facility, and it didn't cost that much. It was maybe $250 million, which is quite cheap for a flagship observatory. So that's Kepler, which really has given a big basis to this subject. Habitability is a tricky concept because it's always referenced to human experience to the Earth. So we assume that habitability at a minimum means a planet that has a stable climate where the temperature is suitable for life and where there's available liquid water. Other than that, we don't say very much because we don't really know very much. Most of the thousands of exoplanets we know, we really don't measure detailed properties of. We know their mass and maybe their size, and that's about it. We're only just approaching the time in this subject where we really learn what these exoplanets are like.
Professor, astrobiology is a fascinating discipline that sits at the crossroad of astronomy, chemistry, geology, and biology. How do you bring all these fields together when evaluating whether a planet could support life? And what does life even mean in that context?
Yes, astrobiology is exciting in part because it is interdisciplinary. Most scientists in the modern world are quite narrow. They work on their little specialty. They don't even know how to speak to someone in another field. A geneticist and an astronomer have trouble having a conversation. Astrobiology is intrinsically interdisciplinary. You have to know about geology to understand what a rocky planet can do, atmospheric physics, biology, of course, chemistry to understand how biology evolved from chemistry, then astronomy, naturally, and planetary science. So this is a wide range of disciplines, and at the meetings of astrobiology, all these people are in the same room, and they actually have to learn how to talk to each other. So astrobiology as a subject has forced scientists who like to be specialized to be a little broader and to learn how to talk to other scientists in adjacent fields. And the interdisciplinary aspect is important because it means you look at the problem from different perspectives. You look at the problem of how life started from the perspective of a chemist or a planetary scientist. And so these different perspectives of different disciplines have been very helpful to the subject.
Professor, there is a quite urgency running through this book. The idea that humanity is degrading Earth while simultaneously searching for a replacement. Do you think the search for exoplanets should motivate us to protect Earth more fiercely, or does it risk giving people a convenient exit strategy?
It's an interesting point, and I did have that in mind writing this book. I was very much aware that we are threatening the only planet we know with life in the universe, which is our own planet. We're threatening its ecosystem, its sustainability, the global environment. Um, the truth is, there is no plan B. There's no planet B. There's no exoplanet that's habitable that will be anywhere we can reach in the foreseeable future. The stars are too far away. We have not left the solar system. Humans haven't even gone past the moon. So there is no conceivable way an exoplanet will be found that's close enough for us to even visit within decades, perhaps a century, because space travel is still quite primitive. So there's no exit strategy implied by a habitable exoplanet, but it will cast a light on how unusual life in the universe is. And we may find out that our planet is really special, not just because it's our home, but because places like it are actually quite unusual. And it will give us a little more of a sort of cosmic obligation to take care of this planet that we've been gifted with. So yes, I hope it does put a little mirror in place to make us look back at our own living planet and do better in taking care of it.
Professor, you explored the concept of habitability extensively. How has our definition of habitability evolved as we have discovered extremophiles, like forms thriving in volcanic vents, acidic lakes, and frozen deserts right here on Earth?
Sure, that the extremophiles are very important for a context for habitability. So yes, life on Earth has radiated into ecological niches that are very extreme, extremes of temperature, pressure, acidity, salinity, and these are not places we could live. These are places where microbes can live, small creatures. So we think that microbes are pretty sturdy and robust and have enormous capabilities in different physical environments, and that should be true elsewhere too. So the extremophiles on Earth are telling us that life elsewhere also is likely to have inhabited, strange and exotic and extreme environments. So habitability means something different for a human than it does for a microbe. And for a microbe, obviously, they are extremely sturdy to radiation as well. But there are microbes that are survived being on the leg of a spacecraft in deep space, subject to the vacuum of space and ultraviolet radiation. So these are extraordinary capabilities that microbes have, and they're telling us that microbes elsewhere in the universe probably have similar capabilities.
Professor, the book discusses the expanding role of private industry in space exploration alongside government agencies. Do you see this shift as accelerating our path to multiplanetary life? Or does commercializing space introduce risks we haven't fully reckoned with?
It's a mixed bag. It's a double-edged sword. The adventures of the space entrepreneurs, of Elon Musk and Jeff Bezos in particular, the two richest people on Earth that also run private space companies. They will claim, and especially they are visionaries, they will claim that their larger goal is to spread humanity beyond the Earth, to terraform Mars, to find us other places to live in the solar system initially. And that's their dream. That's not their business, though. Their business is really launching satellites. And so these companies still have to make money. They have to pay their shareholders. They have to satisfy the people who invest in them. And that's not always done for the basis of pure science. So I don't think they're motivated by pure science, by astrobiology. And I don't even really believe that us being a multiplanetary species is something that's going to happen in the next few decades, maybe not in a century. So we have to sort of separate the visionary aspect of these entrepreneurs from the hard-nosed business pragmatics of how they actually run a business. And they're not the same thing.
Professor, if we were to one day establish a human civilization on a distant, habitable exoplanet, what would be the greatest challenge? The physics of getting there, the biology of surviving there, or the psychology of leaving Earth behind forever?
Those are three good things to think about in this situation. I mean, the physics is the one that it starts with, and that's why my timeline for us leaving the Earth, even leaving the solar system, is probably century rather than decades. Um, the energy cost of going to another star, trillions of miles at a minimum, tens or hundreds of trillions of miles, the energy cost is phenomenal to send humans spacecraft. So that physics, it's hard to get around that physics. We will almost certainly need to have new propulsion technologies, and we will also need to have a mode of suspended animation to put people down into a wait state biologically so they can survive the trip, which will probably take centuries or millennia. So those are constraints of physics and biology, actually. The biology of living on a different planet is also interesting because another planet that we find will not be exactly like the Earth. It will have subtle and maybe profound differences. We may be vulnerable to pathogens or biological creatures on a new world, even if it's habitable and has breathable air, that would eradicate the colonists that go there. So there are extreme hazards associated with occupying a new world and bringing your biology to a world that may already have biology. And that's a wild card. It's really hard to anticipate how that would go. The psychological aspect that you mentioned, that's also important. There's going to be a self-selection operating. The people who volunteer for a trip like this, just like the first people who volunteered to go to Mars, even for a short time, or maybe to become colonists, they will self-select to be adventurous people, very fiercely independent, technology forward, so adopting technologies that they will need to survive, in fact. So there is an issue of isolation, of course, and separation from the home planet. But the people who feel that most acutely are not going to volunteer for the trip. So I think the people who do this will have the kind of spirit that took humans across the planet when we left Africa and when we migrated across the planet to strange places. Even though we had comfortable places where we came from, we're explorers. So the explorers among us will do this adventurous thing.
Professor, I'd like to conclude this episode with one final question. At the end of this remarkable journey through exoplanets, astrobiology, and the future of humanity, what is one thing you most hope readers and perhaps our next generation of scientists take away from Worlds Without End?
I think what I hope they would take away is that it's almost an inevitability that there's life beyond Earth. I mean, the ingredients are there, the habitable locations are there all through the universe. It's just a matter of technology and time for astronomers to be able to find that life, because it may not be right next door. So that's the real message, that the universe, it's almost certain we live in a biological universe, and it's not confined to this one planet. And the discovery of that first life beyond Earth will be earth-shaking, literally and metaphorically. It'll be a profound event in the history of science, but also of humanity, because it'll recast how we understand ourselves when we live in a universe where biology is not confined to this one planet.
And that, dear listeners, brings us to the end of a truly cosmic conversation. Professor Chris Impey has taken us on a journey that spans billions of light years from the fragile beauty of our own planet to the thrilling possibility of worlds waiting to be found. What stays with me is this: the universe is far larger, far more generous, and far more mysteries than we dare to imagine. Thank you, Professor Chris, for your time, your wisdom, and your research, and for reminding us that curiosity itself may be humanity's greatest survival tool. It has been an absolute privilege having you on Business Talk. They say space is infinite, and so it seems is your generosity is sharing it with the world. Professor Chris Impey, thank you so much for everything. Thank you once again.
It was a pleasure to be with you, Deepak. I enjoyed the conversation. Thank you.